module you shall be able to understand what are dyes and pigments. Although this is not a new term to you, but as forensic scientists you should go into more details so that you can correlate when you are using them for analysis and otherwise in the crime scene. So, we shall study what are dyes and pigments, what is the difference between dyes and pigments, and what are the different types of dyes and their application. And then we shall study how the forensic examinations of dyes is carried out. In the last module, we have learnt about cosmetics and their analysis. We studied the cosmetic product can be defined as substances used for external looks enhancement, clearing, perfuming, improving the body appearance, curing the body odor and or keeping them in good condition. And we have gone into the details of categorization into oil, cream, powder, lotion, emulsions, etc. And we also studied how they are analyzed. In this particular module, we shall do a similar treatment to the dyes. The dyes, as you are already aware, are coloring organic materials which have affinity to adhere with solvent medium, and thus they are used for imparting color to a substrate which can be cloth, paper, plastic, leather and so on, and in a reasonably permanent fashion. Unlike the other organic compounds, dyes are colorful in nature. And why this happens? Because they absorb light in the visible spectrum range, which is 400 to 700 nanometers. Dyes contain in their structure at least one chromophore. And when we say chromophore, what do we mean by this? Chromophore is a color bearing group or unit, and the speciality about these chromophore is that you can easily recognize them because they are consisted of a conjugated system. And due to conjugation, they exhibit resonance of electrons, and as all phenomena, it is responsible for color of the compound. That is, this resonance or the shifting of electrons is responsible for the exhibition of color by these compounds. If any one of the phenomena is not there, then these molecules will no longer be colorful. That is, in these chromophore, if you decrease the conjugation or remove these conjugations altogether, then these colored substance will go into colorless substance. There are some other groups in addition to chromophore which are responsible for color of a compound, and these are called as oxochromes. Oxochromes are also referred to as color helpers or color enhancers. So, chromophore is the basic unit and oxochromes are the group which are helping in enhancing the color, and obviously when they are positioned in such a way that they will be enhancing the conjugation, the color gets enhanced. Some commonly known oxochromes are carboxylic acid, sulfonic acids, amino and hydroxyl groups, and these are the ones which can easily take part. Either they will be donating the electrons to the conjugated system, or they can easily withdraw the electrons from the conjugated system. Shown here are the wavelengths of the light absorption versus the color in organic dyes. So, if the color you can see is absorbed in 400 to 435 nanometer range, the color absorbed will be violet, but its complementary color, the yellow green, will be the color observed. Similarly, if the color absorbed is blue, the compound will appear to be yellow. If it absorbs blue green, it will appear to be red. If it absorbs yellow green, it will appear to be violet, and so on. Synthetic dye, if we talk about, was accidentally discovered by William Perkins in almost 1856. William Perkins was an English chemist, and while he was doing an experiment on synthesizing quinine in aniline medium, he accidentally discovered this dye. And before that time, all the dyeing materials were taken out from either the barks or the roots or the seeds or the leaves or shellfish and then utilized as dyes. But then from this point onwards, millions of now dyes have been made, and most synthetic dye stuffs are prepared from coal tar derivatives. Their making is a highly complicated technical operation which is also constantly changing. But then one negative impact is the environmental, so there should be some methods which are more environmental friendly which should be used for these dyes, and even when the dyes are used, the material which is left over should be properly treated before it is thrown in the environment. So, all these cautions should be there. But then from forensic point of view, we will focus less on that part and we will see that how these dyes which are there as a part of cloth or paper or something which are then found at the crime scene, and then that will give an important clue which can be taken by doing proper forensic analysis. So, with this background, let us study more about the dyes, pigments, the difference between them, the applications, so that we are aware where all the dyes are used and then how the analysis is done. And let us do all this with the help of graphics and visuals.
Difference between dyes and pigments. In respect to their solubility, organic colorants fall into two classes, that is, dyes and pigments. Difference between the dyes and the pigment is that dyes are soluble in water and are also soluble in organic solvents. On the other hand, pigments are usually insoluble in both. Dyes can be used to color any substance, but pigments are used only to color polymeric substrate because mechanism of pigment differ from that of dyes. This involves only coloration because pigments can mix with the polymer prior to the formation of article. Pigments do not interact with the substrate and hence do not destroy the crystal structure of the substrate. Mordant. While some fabrics such as wool and silk can be colored merely by dipping the fabric in the dye, many other fabrics such as cotton need a mordant. A mordant is a substance which helps in chemical reaction which takes place amid the dye and the fiber so that the dye is absorbed. Examples: alum, iron, copper, tin, blue, vitriol, tannic acid, etc. Characteristics of dye. All colored substances are not dyes. Some of the important features of the true dyes are given below. It must have a suitable and attractive color. It must be able to attach itself to material from solution or to be capable of fixed on it. Should be soluble in water or must form a stable and good dispersion in water. When fixed on a surface, should not remove easily. Types of dyes. The dyes are generally classified on the basis of their chemical properties and its different applications. Natural dyes. Natural dyes, as the name proposes, are the dyes acquired from natural resources. They are mostly organic compounds which are colored. Earlier, people used to dye their textiles using common, locally available materials. scarce dyestuffs that produced brilliant and permanent colors such as the natural invertebrate dyes, Tyrian purple, and crimson kermes were highly prized luxury items in the ancient and medieval world. Plant-based dyes such as indigo, saffron, and five madar were raised commercially and were important trade goods in the economies of Asia and Europe. Across Asia and Africa, pattern fabrics were produced using resist dyeing techniques to control the absorption of color in piece dyed cloths. Natural dyes can be classified into three types: natural dyes obtained from plants, indigo; those obtained from animals, cochineal; and those obtained from minerals, ochre. Example of dyes manufactured from plants: logwood, indigo. Parts of plants from which dye can be extracted include roots, berries, barks, leaves, and wood, fungi, and lichens. Examples of dyes manufactured from animals: Tyrian purple. Example of dyes manufactured from minerals: Prussian blue, ochre. Synthetic dyes. Synthetic dyes, as the name suggests, are man-made. The first human-made synthetic organic dye, morphine, was discovered serendipitously by William Henry Perkin in 1856. Many thousands of synthetic dyes have since been prepared. Synthetic dyes quickly replaced the traditional natural dyes as they used to impart better properties to the dyed materials. These are mostly colored, organic compounds, and majority of them are made from coal tar derivatives. Synthetic dyes are used for modern clothing. These dyes are obtained by adding different colors to the natural dyes. They are easy to use, less expensive, and have explicit range of colors. Examples of synthetic dyes are artificial alizarin obtained from coal tar anthracene, phthalate dyes, alizarin, triphenyl methane dyes, etc. Classification of dyes on the basis of their dyeing processes. Further, these are also classified in various ways according to their method of application, chemical composition, and intermediates from which they are prepared. Colorants are dispersed in a suitable solvent, mostly water, for formation of dye and bringing the system into contact with the material to be dyed. According to the process of dyeing, dyes are classified into the following types. Acid dyes. Acetic dyes are water-soluble dyes containing sodium salts of the color acids which may contain sulfonic acid group, usually present as sodium sulfonate salts, and phenolic acid groups. These produce a negative charge on the molecule of dye and increase its solubility in water. These are used to dye fibers having basic groups such as wool, silk, and polyamides. Example: picric acid, metanyl yellow, naphthol yellow, etc. Typical fixation percentage 80 to 93. Basic dyes. Basic dyes are cationic stain and reacts with negatively charged material. Basic dyes comprise of amino or alkyl amino group which is protonated under the acidic conditions of the fibers by formation of salt linkages with anionic or acidic group in fibers. As their color base is indissoluble in water, this can be achieved by the conversion of base into salt. They generally give rise intense and brilliant shades and have poor light fastness. These are used for dyeing silk and wood directly. Example: methyl violet, crystal violet, methylene blue, rhodamine, etc. Typical fixation percentage 97 to 98. Mordant or adjective dyes. These dyes have poor affinity for the fibers. However, these dyes require a pre-treatment of the fibers with a mordant material designated to bind the dyes. The mordant gets attached to the fiber and then combines with the dye to form an insoluble complex called a lake. Modern dyes are fixing agents and help in improving the color fastness of those acid dyes, which have the capability to form metal ion complexes. Example: mordant such as aluminium, chromium, iron salts are used depending upon the fibers and the class of the dye. Direct dyes. Direct dyes are also known as substantive dyes and are most frequently used as paper dyes. Initially, direct dyes were used for dyeing cotton. Such dyes exhibit the capability to adsorb onto the fibers from an aqueous medium as well as the ability to become bound to the fiber. These are class of dyes that become strongly adsorbed on cellulose. These usually bear sulfonic acid groups. Direct dyes are large, flat, linear molecule which can enter the water-swollen amorphous of cellulose. This dye is primarily used to color plain ground which are later to be printed in a pattern with vat dyes. Example: Congo red, typical fixation percentage 70 to 95. Reactive dyes. Reactive dyes are those dyes which form a covalent bond between the dye and fiber. Such dyes have a reactive group, mostly trichlorotriazine, either a haloheterocycle or an activated double bond, which once applied to a fiber in an alkaline dye bath forms a chemical bond with a hydroxyl group on the cellulosic fiber. Chromophore in a reactive dye has a substituent that is activated and allowed to directly react to the surface of the substrate. Typical fixation percentage 60 to 90. Vat dyes. Like sulfur dyes, these dyes are insoluble. Therefore, these dyes are applied in their reduced forms, which are obtained by treating the compound with some reducing agent such as alkaline sodium hyposulfite in a large wooden vat, giving rise to the name vat dyes. After the reduced dye has been adsorbed on the fiber, the original insoluble dye is reformed by oxidation with air or chemicals. Vat dyes are thought to be primeval class of dyes and are based on the original natural dye. Indigo and its close chemical relative Tyrian purple. Cotton, wool, as well as other fibers can be dyed using vat dyes. The dye is soluble only in oxygen-free, reduced form. Vat dyeing takes place in a bucket or vat. Example: anthraquinone, indigo, quinol. Typical fixation percentage 80 to 95. Disperse dyes. Dispersed dyes are non-ionic, ready-made dyes. They are not soluble in water. They are organic coloring substances. Opt for dyeing hydrophobic fibers. Dispersion dye molecules are generally small and have some hydroxyl or amino group to give finite water solubility at dyeing temperature. These are used for dyeing artificial cellulose ester, cellulose acetate, and synthetic fibers, especially acetate and polyester fibers, and sometimes nylon and acrylic fibers. Typical fixation percentage 80 to 92. Azo dyes. Azo dye is a class of synthetic dyes containing nitrogen as the azo group. These dyes give bright colors showing fair to good fastness properties. The process of its manufacturing is cost effective. The formula for preparing an azo dye involves two organic compounds, a coupling component and a diazo component. In the usual procedure for the development of azoic dyes, the fiber is first impregnated with an alkaline solution of the coupling component. This is then treated with the solution of diazonium compound. The major application of azoic dyes are the dyeing and printing of cellulose fibers like cotton. Oxidation dyes. These dyes are produced in textile fibers by oxidation of colorless compound. Example: aniline is oxidized in cotton with sodium dichromate in the presence of a metal catalyst to produce an aniline black. Solvent dyes. These dyes do not contain sulfur other than water solubilizing groups. These are soluble in organic solvents, the nature of which varies according to application. These dyes are used for manufacture of varnishes, typewritten ribbon, candles, polish, shop, cosmetics, etc. Food dyes. Food dye is another class of dye that describes the role of dyes in food coloration. Because food dyes are classed as food additives, they are manufactured to a higher standard than some industrial dyes. Food dyes can be direct, mordant, and vat dyes, and their use is strictly controlled by legislation. Many are azo dyes, although anthraquinone and triphenylmethane compounds are used for color such as green and blue. Some naturally occurring dyes are also used. Forensic analysis of dyes. Textile fibers are a key form of trace evidence, and the ability to reliably or discriminate them is crucial for forensic scientists worldwide. While microscopic and instrumental analysis can be used to determine the composition of the fiber itself, additional specificity is gained by examining fiber color. This is particularly important when the bulk composition of the fiber is relatively uniformative, as it is with cotton, wool, or other natural fibers. Such analyses pose several problems, including extremely small sample sizes, the desire for non-destructive techniques, and the vast complexity of modern dye compositions. The increased use of multivariate statistics and other data analysis techniques for the differentiation of spectra from dyed fibers will also be discussed. Preliminary examination of dyes is done by thin layer chromatography, which helps in separation and identification of the dyes, whereas the confirmatory examinations of dyes are done by variety of chromatographic tools in combination with spectroscopic tool. The instruments like GCMS, LCMS, and fluorescence spectroscopy are readily used. Toxicological considerations. While dye substrate affinity is critical, synthetic dyes cannot be commercialized unless they pose little health risk under end use conditions. Consequently, environmental safety is an essential consideration in molecular design. In this regard, the raw materials employed in the manufacture of synthetic dyes should not involve compounds known to pose health risks. This would include a large group of aromatic amines that are neither cancer suspected agents or established mutagens. It is clear, therefore, that dye design must take into consideration the likely genotoxicity of the potential metabolites generated in mammalian systems. In the case of azo dyes, the enzyme mediated formation of genotoxic aromatic amines as metabolites must be considered, since it is possible that the entire dye is safe, but not all of its metabolites. Some of the dye could lead to the formation of the bladder carcinogen, like benzidine, if this dye were taken up in the body. As dyes are chemical compounds with their characteristic structure, these can easily be identified through spectrophotometric techniques like UV visible, IR, and mass spectrophotometry.
So let us now summarize what we have learned in this module. Dear students, we have learnt about dyes in this particular module and how they can be investigated in a forensic lab when they are found in crime scene. In order to add color to any substance or to change the color, dyes are used. And we have studied that dyes can be synthetic as well as natural substance. A dye is an organic molecule that is soluble in any solvent and absorbs light at visible wavelengths, while a pigment is the coloring material that can be dissolved only in oil and they are used to make paints. Dyes are commercially used in plastic industry, food industry, textile industry as the important ones, and many others. We also studied that most commonly dyes which are used in day-to-day life are the reactive and direct type of dyes, and especially they are used for cotton dyeing. We also studied the disperse dyes. The dispersed type of dye are again commonly used and they are used for polyester dyeing. Reactive dyes react with fiber molecules to form chemical bonds. On the other hand, direct dyes can color fabric directly with one operation or other without the aid of any fixing agent. We studied that direct dyes are the simplest dyes to apply and they are also the cheapest one. We also studied how the TLC, that is the thin layer chromatography, is used to separate the dye mixture and can help in identification of these dyes, because each dye will have a particular RF value, and by comparing with the reference case you can come to know, yes, this which is obtained as in sample from the crime scene is matching with this particular dye. We also studied that dyes are examined by different type of instrumental techniques also, like fluorescence spectroscopy, LCMS and GCMS. And we also studied the forensic examination and the toxicological consideration of dyes that we have to keep in mind.